Good morning, ladies and gentlemen. We are back to Region Max. You're all welcome. How are you and how was your night? Hope it was fine. It's okay. This morning we'll be looking at calculus on implicit functions. I know, don't be surprised or get confused with the word implicit function. So before we do anything this morning, please I want you to like, comment, share, and make sure you should attend the class, and don't forget. It's okay. Here we have the definition of implicit functions. An implicit function is a function in which the dependent variable y is not written explicitly in terms of the independent variable x. That is, instead of x and y appear together in one equation. Amen? So, what is this definition trying to say is this. Ordinarily, we know function, two of us. When we have an equation of this form, x squared, y equals x squared plus c. This is a function, two of us. So, this equation, it is not an implicit function, but it is known as what? Explicit function. That is explicit function. This is an explicit function. So what you normally do, you differentiate explicit functions of this form. Sometimes you have s squared plus x plus let's say 2. This is an explicit function. Please take notes. Is that clear? Hope you are following. Please look at the board very well. I want you guys to look at the board very well. Okay. So, please, I want you to like. Is that clear? Send stars too. Okay. So, this is an explicit function. But today we are not looking at explicit function. I've taught you in class how to differentiate explicit function. Today we'll be looking at implicit functions. It means implicit functions are always in the form either x plus y equals to 2x or y squared plus x squared 25 x squared equals to either 0 or y squared x squared plus y x squared equals to 2xy. This is an example of implicit function. Take note. So whenever you are asked to write one or two examples of implicit functions, this is what you are supposed to write. Is that clear? Is there any question? So take note of the definition, should in case you are asked to define an implicit function. Any question before we proceed further? Is that clear? Please try and invite others who are not here. You are supposed to be 300 or something, but it's only 36 that is here. Oh, this person say you does not understand. Abdul, you don't understand. Okay, what I'm trying to say, I've not started solving any problem. I'm just trying to let you know that implicit function, this is the definition. It says an implicit function is a function in which the dependent variable y is not written explicitly in terms of the independent variable x. That is, instead of x and y appear together in one equation. You know, in class, I told us that when we have ax, y equals to ax raised to the powers of n, true or false, we call this dependent variable, isn't it? That was yesterday, dependent variable. Then this is called independent variable, true or false, if I'm not mistaken. Right. While this is called index, then this is called a constant, the a, true or false, true or false. So now the definition is talking about this y, the dependent variable. Look at it here. The dependent variable y is not written explicitly in terms of the independent variable. That is what it means. It means it is not in this form, that is y equals to either x plus c. That is what it means. It is not in this form. So if it is not in this form and it is in this form, is what we call implicit functions. Why this is known as explicit. Please, those of you that are just coming, is known as explicit function. Please take note. Is that clear? Explicit function. Any question, please? So, before we proceed further to integrate, true or false, it's okay. So, that is that. So, before I integrate, differentiate or cite any example, or illustrate any example here, let me remind us with the word differentiation, because everything we are going to do here will be making use of a differentiation. So if you don't know how to differentiate, that is a very big problem. Is that clear? So now, this is a function. If y is equals to ax raised to the powers of n, and you are asked to find dy all over the x, the reason why we are asked to find dy all over the x is because y is the dependent variable, while x is the independent variable. So it is called what? Y all over what? Yes. So supposing here is y equals to 8 raised to the powers of n, it means they are asking you to find the y. The independent variable here is what? Is t. The t. Take note. So it's very important. Not necessarily you are going to see here x. Is that clear? Likewise here too. Not necessarily you are going to see here y. Sometimes you may see p equals to a theta raised to the power n. So it means if we are asked to, they will ask you to find the p all over what? The theta. True or false? True or false? Look at the board. Are you seeing? Okay. Look at the board. Somebody is trying to say, can you explain it again? I have not started doing any example. I'm just trying to tell you that this is a dependent variable, while this x is independent variable. So that is why they are saying find the y over the t. Likewise, look at this function. Y is equals to t. So y is dependent variable. You can now see that the independent variable here is t. That is why we are saying the y all over what? The t. Look here. The dependent variable here is what? P. The independent variable here is what? Theta. So that is why you are saying the P all over the theta. So it means we have to look for the P all over the theta technique. So now let us define differentiation mathematically here. As long as differentiation is concerned, what we need to do here is our y equals to ax raised to the powers of n. So if we are to find the y all over the x, it means our dy all over the x is equals to, note that this is a constant, which is a. So what we have here, n. Use n to multiply any constant that is here. Is that clear? So n times a, it could be n a x raised to the powers of n minus 1, because multiplication is commutative. Yeah. Or this is the same thing as the y all over the x. If you want to go by alphabetically, it means a before n. Either a n x raised to the powers of minus 1. So this is the formula for differentiation, and this is what we'll be doing all through today. Is that clear? We are going to use this formula to differentiate implicit functions. So don't get confused whether it is written NA x raised to the powers of n minus 1. Please note, don't write it in this way, because students are very funny. Don't write it in this form. Yeah, this is not an x raised to power n. Rather, this is an x n minus 1. So this is wrong. Why this is good? Take note. Any question, please? Any question? Yes or no? No question? So we can move further to consider some examples this morning. It's okay. So let's proceed. Please, I want you guys to like and share the link to your friends. Share the link with your friends, and don't forget to share it immediately after the class. I'll be very grateful. It's okay. So let's move further to consider some examples. We will solve examples upon examples. I know very well that those of you who were in class yesterday will definitely enjoy what I want to do. Yeah. So let's look at some examples here. Example, if x squared, right? If x squared plus y squared equals to 25, find the y all over the x. I want everybody to look at the board. I hope you are copying. Write it down inside your calculus notes. It's very important because it will do you good. Is that clear? So now look at this question. We want to look at this question. Hope you are seeing it clearly. You are seeing it clearly. 12b, favor Moses. So meaning it is same formula as it's the same differentiation we want to do. It's the same differentiation. It's okay. So now what we need to do here is we write solution. Then our x squared plus y squared equals to what? 25. So when you come across equations like this and you are asked to find the derivative, of dy all over dx, what should first come into your mind is look at the function. This function, this is an implicit function, true of us. So if I were you, you apply this, you use this, d all over dx, open bracket, what is here? X squared plus, what we have here, plus d all over dx, open bracket, what is here? Y squared, then equals to d all over dx, what we have here? 25, right? 25. Amen? Yeah, amen. It's okay. So, if this d all over dx means differentiate what is inside there, then this d all over dx means differentiate what is inside there. Also, the d all over dx means differentiate what is inside there. So now, with the examples we have examined so far, both in class and here, if you are asked to differentiate x squared, you know that you are going to have here 2x, true of us, 2x, what do you have here? Dx. This dx means you differentiated for what? X, all over the existing dx. Do you understand here? Do you understand? Any question before I proceed? Look at the board, please. Look at the board. Do you understand? Any question? Any question? No. Okay. Yeah. No question? Yeah. Okay. We can proceed, right? So you all understand how we got, because if you differentiate this, you are going to have 2x. This is it. If you differentiate x squared, you have 2x dx. This dx means you differentiated for x because there was no x here. Please take note. All over the existing dx. Then what do we have here? Plus, right? Plus. Then the same thing. We are going to differentiate y squared. If we differentiate y squared, we are going to have 2y, two of us. 2y, d what? dy, all over the existing dx. Why? Because you differentiated for y. That is why we are saying y. Sorry, dy here. Then equals to, this is called what? A constant. Neither the independent variable or the dependent variable is attached to this, two of us. So it means this is a constant. And when you differentiate a constant, it gives what? 0. Two of us. So here will be 0. Is there any question that you want to ask at this point before we proceed? Please drop it in the comment section. I'm waiting for you. Any question? Oh, I should come again. Somebody say he doesn't understand. Okay. The last part is okay. Yeah. What I'm trying to do is this. When you have d all over dx, open bracket, y squared, note that they are asking you to differentiate what is inside there. So now, this is your n, two of us. Your 2 is your n. So if we are to differentiate this, it means this will going to give us 2y raised to the powers of 2 minus 1, two of us. Then d what? Y, because you differentiated for y all over the existing dx. Can you see now? All over dx. So now here we are going to have 2y. 2 minus 1 is what? 1. And it's not necessary we should write it this way. 2y raised to the power 1 dy all over dx. It is not necessary. We all know that 1 exists. So this is the reason why we obtain this. Please, any question again? Do you understand? Are you following? Are you following? Yes or no? Please, people should answer me. You are following, right? Okay, so can we continue? Can we continue? B9, I know you are just coming regular. Okay, we can continue, right? Okay. So now, here, amen, here, look here, you know, they ask us to find the y over the x. So look at this equation. Look at this. We want to do something. Look at it. If we have a all over a, what do you think will be the answer? Is it not 1? Yeah, it's 1, true or false? So what if we now have the x all over the x? What do you think we are supposed to have? We are supposed to have what? 1, true or false? So it means this and this will cancel. We'll be left with what? 2x. But mind you, this and this cannot cancel because this is the y, this is the x. The reason why this and this cancel is this is the x, this is the x. So everything turned to what? 1. So by the time you use 1 to multiply 2x, it's the same thing as what? 2x. Amen? Amen. It's okay. So far, so good. So here will now be 2x plus 2y dy all over the x equals to 0. Amen? Okay. So now, look at it. Look at it. Now, look at it. So now what we need to do here is we have to take this to this right hand side. You know, in your elementary mathematics, JS2, if I'm not mistaken, if we have x plus 2 equals to 3, this is a linear equation, true or false? So if we collect right hands or take these 2 to this side, you know that because of this plus, everything will now be minus what? 2. True or false? It's true, right? That is what we want to do. Because plus crosses the sign of equality becomes minus. But supposing here is minus, by the time it crosses the sign of equality, like assuming we have x minus 2 equals to 3. So by the time minus 2 crosses the sign of equality to this side, it will now be what? Plus. Take note, because of what I want to do something. Do you understand? Are you following? Okay. So far, so good. So if you agree with me, so here we are going to left with the left hand side will be 2y, the y all over the x is equals to, note that there is an invisible plus here, true or false? So if this plus 2x crosses this sign of equality, it becomes what? Minus 2x. True or false? Yeah. So then, since we are asked to find the y over the x, but here we have 2y dy over the x, so what we are going to do here, hope you understand and you are following too. What we are going to do here is we are going to divide 2 by what? 2y. So we now write divide 2 by 2y. So it means this is how it's supposed to be. 2y dy all over the x all over 2y equals to minus 2x all over what? 2y. So this and this will go. Can you see now? We said we should find the y all over the x. So the left hand side now be dy all over the x now be equals to this and this will cancel, minus x all over y, or all over y. This is the final answer. Please, any question? Any question, please? Ask your question, please. Ask your question. Oh, somebody is telling me to come again. Where? Somebody is telling me to come again. Where do you want me to repeat? Benjamin, Dama John, sir, what about the 25? Okay, I think you are just coming. You are just coming. The second state of the solution, how you arrive it. The second state of the solution, I think some of you are just coming. Look at it. What we did here is, there is no magic here. What we did here is, look at it. Anytime you want to differentiate implicit function, just approach it this way. Like we have x squared plus y squared equals to 25. So at this point, look at the board. Those of you that came late, some of you came late. Yeah, you came late. So now what you need to do here is you apply d all over the x, open bracket, x squared plus d all over the x, open bracket, y squared equals to d all over the x, open bracket, what, 25, close the bracket. So this means that differentiate what is inside there. Then if we apply the general rule for differentiation, you know that this 2 is your n, true or false. It means the powers you are going to minus 1 from the 2. So if that is taken, then use the 2 to multiply any coefficient here. So that is why you see here 2x. This d will now be dx all over the already existing dx. Can you see now? Amen? Yeah. So that is the reason why we obtain dx all over, 2x dx all over dx, then plus the same thing applicable when you differentiate y squared. You are going to have 2y d what? dy. It means you differentiated for what? All over the existing. This dy means you differentiated for y. Then equals to, here there is no variable attached to this 25. Look at it here. It is only 25. There is no y, there is no x here. True or false? So this is a constant. So whenever you differentiate a constant, it gives you 0. That is why we obtain 0 here. Do you understand? Then here, at this point, the reason why we have 2x is because the x divided the x, is it not 1? It's 1. True or false? So here, 1 times 2x, that is why we have 2x plus, we cannot, this and this cannot cancel. 2y all over, 2y dy all over what? The x equals to 0. So at this point, what you need to do, you have to apply your linear equation, true or false. I think I demonstrated it here. It means you take this to this right answer. By the time already we have an existing positive here, plus here. So if this plus 2x crosses the sign of equality, becomes what? Minus. So the left answer will now be 2y dy all over the x equals to 2x. Do you understand? Please, any question? Any question? Is there any question? If there is no question, we can proceed, right? Can we proceed? Okay. Thank you for your understanding. It's okay. So let's proceed further to consider more examples. So it means I can clean, right? Hope you are copying. Please, it's very important. Very, very important. Okay, let us consider more example. More example. Make sure you copy. More example. Okay. Okay. The question says if we have x squared plus x squared plus xy, then plus y squared equals to 7. We said find dy all over dx. As simple as ABC. We write solution. Let us write solution. Our x squared plus xy plus y squared is equals to 7. Please, I want you to pay attention to this particular one that we want to look at. Is that clear? Something has been added, two of us. What is added here is x squared. So, xy, two of us. So look at the board very well. I want you to look at the board very well. Please look at the board very well. Xy is added here. So now it's the same approach. Is that clear? So we now write d all over dx. Open bracket. What is here? X squared. And what is here? Plus. Then d all over dx. What is here? Xy. Open bracket xy. Close the bracket. Then plus d all over dx. What is here? Y squared. Close the bracket. Equals to d all over what? Dx. Open bracket y. Can you see now? Open bracket 7. Close bracket. Already we know that this is 0. Two of us. This is 0. Two of us. You don't need a prophet to tell you. Amen? It's true, right? So, the same approach, if we differentiate x squared, we are going to have what? 2x dx all over dx. Amen? Then, plus, this is where the problem will be. Is that clear? This is where the problem will be. Here, we are going to use what is called product rule, although I have not taught you how to use the product rule. But I'll make you understand. Is that clear? To differentiate it direct. So now, here we have two functions. We have x and what? Y. It is either you first differentiate x whole y, or you first differentiate y and whole x, then differentiate the remaining one later. Whichever way you want to do it. Amen? So, if now, look at it, let me do it here. D all over the x, open bracket, x, y. Listen, so, if we differentiate x, note that there is an invisible one here, two of us. So, this one will multiply whatever that is here to give us what? 1 times x raised to the power of, this is n, right? 1 minus 1. Two of us. Then this will going to give us 1 times x raised to the power of 1 minus 1 is 0. But mind you, y, you hold y constant. Keep it like this. Is that clear? So now, anything raised to the power 0 is what? 1 times 1. This dot means 1, not 0.2. So it means 1 times 1 is 1. So when you differentiate x, it means you hold this one, y, as constant. So when you differentiate x, what do you have? You have 1. So you use this one to multiply this 1, y. So it means this is how it will be. Y the what? The x, because 1 times y is what? Y. The x all over what? This existing the x. Then, since there are two functions, you are going to put plus, then this time around you are going to hold what? X constant. So you are going to differentiate y. So if you differentiate y, 1, true or false? 1 times this is going to give us 1 dot y raised to the power of 1 minus 1, which is the same thing as 1 dot y raised to the power of 1 minus 1 is 0. So anything 1 times anything raised to the power 0 is what? 1. So you can now see that 1 times 1, 1. So you can now see that 1 times x is what? X, isn't it? So it means x dy what? Dy, because it differentiated for y, dy all over the x. So this is the answer. This is the answer to this. X, y. D all over the x, open bracket, xy. This is the answer. Do you understand, please? Even though you don't understand it here, when I come to class, I will just do brief. Yeah, somebody say you are lost. It's okay, sorry, but you are not. Okay, so now, yeah, somebody is telling me I should come again. Look at it here. We have two functions here. This is so when you come across functions like this, you are applying product rule. Don't worry, by the time I teach you product rule, you understand what I'm trying to do here. So now, hold one, either x or y. Just keep it aside. Is that clear? So let's say, let us keep the y aside. So you can now see that we are differentiating x. True or false? If you differentiate x, what are you supposed to have? Is it not 1? If you differentiate x, dy, if you differentiate x, you are going to have what? The x all over the x. True or false? Because this means you differentiated for x. So this is the same thing as this and this will go 1 times 1, which is equal to what? 1. True or false? So this answer, use it to multiply this y that is here. 1 times what? Y. True or false? That is why you are saying y dx all over what? But if you say you want to, like, it has been cancelled, this is the same thing as this, true or false? Just y alone. But I just want us to understand, we have already cancelled it here. True or false? Just y alone. But for the sake of Marians, let us just, yeah, this is it. It means, okay, it means 1. The x all over the x. So you are using this to multiply this. That is why you are saying y the x all over the x. Then plus, so it means this time around you are going to hold what? X constant, then differentiate y. That is d all over the x, open bracket, y. We're going to give us what? 1 times dy all over dx. Because if you differentiate y, you are going to have 1, true or false. So now you are going to use this to multiply x. So that is why you are saying 1 times x, x dy all over what? Dx. Do you understand? Are you following, please? Do you understand? Oh, the camera is not clear. Sorry about that. I think it should be network. But I don't know whether it's where you are. Oh, it is much better than this one. Okay, so now it means let's proceed, please. Let us proceed. This means that here, let us hold y constant, differentiate x. If we differentiate x, we are going to have the x all over the, and that is the 1, that is 1 dx all over dx. Then use it to multiply y. We are going to have y dx all over dx. Then plus whole x differentiate y. We are going to have 1 dy all over dx. Then use it to multiply x. We will have x dy all over what? Dx. Then what do we have here? Plus, let us differentiate y square. We are going to have 2y dy all over dx. Then here, if we differentiate 7, is what? 0. True or false? True or false? It is true, right? Differentiate 7 is 0. So B13, you are active. So far, so good. Okay, so you don't understand. I said these two functions gives us this from here to here. Look at it. Then we have what? Plus this. We have to differentiate this equals to 0. So don't get confused. I've explained it before again and again. Please, even though you don't understand, in class, in our physical class, I'll do my best for you to understand it better. It's okay. So now, this and this will go. This and this will go. Two of us. So here we have 2x plus here will be what? Y plus x dy all over dx. Then plus 2y dy all over what? Dx equals to 0. Hope you understand up to this point. Do you understand up to this point? Do you understand up to this point? Okay. Do you understand up to this point? Look at the board, please. You don't understand up to this point. Why? Oh, look at it here now. Look at it. We have 2x dx all over dx. Just like 2 divide 2 or 1 divide 1. Is it not 1? You use 1 to multiply 2x. Is it not 2x? Here we have dx, y dx all over dx. The same thing, 1 divide 1 is 1 times y is y. Then we have x dy all over dx. Look at it, x dy all over dx. Plus 2y dy all over dx plus 2y dy all over dx equals to what? 0. So what is that you don't understand again, please? Okay, so as you can see, this and this are the same thing. Go back to your linear algebra. This and this, we can take this to this right hand side. So when we do that, this will be on the left hand side. X dy all over the x plus 2y dy all over the x is equals to, if you take 2y to this, we are going to have minus 2x. Then likewise, if you take plus y to this right hand side, you have minus y, isn't it? So look at it, we are asked to find dy over the x. If you can see what I am saying on the board, you don't need a prophet to tell you. True or false? Something is common. Look at the left hand side. I hope you understand it up to here. Please look at the board. Look at the board. Something is common there. Look at the left hand side. Look at the left hand side. Please make sure you like. Look at the left hand side. Look at it. When you take 2x, here we have invisible plus here. Plus 2x to the right hand side minus 2x. True or false? Your linear algebra, that is GS2. Then we have plus y to this right hand side. You are going to have minus y. Then we'll be left with x dy. Look at it here, all over the x, plus 2y dy all over the x. So look at the left hand side. Somebody should tell me what is common. I will give you half mark. Drop it in the comment section. Type it. What is common? I will give you half mark. Oh, dy all over the x. This person, what is the name? Okay. Another person again. Dy all over the x. Thank you very much. You are good to go. I love that. Oh, this person, not x and y. They are not common. Then this other person. Yeah, I love that. I'm going to give you half mark. Please don't copy someone's question. Some of you are copying someone's question. I can see that. Someone's answer, sorry. Some of you are copying. When I come to class, remind me, I will give you guys half mark. It's okay. So dy all over there, so we have to factor it out. Let us factor it out. When we factor dy all over the x, open bracket, x plus 2y. Can you see now? This is equals to minus 2x minus y. True or false? Amen? Okay. So now, they say find dy all over the x. Already, you don't need the prophet to tell you. Who can tell us the next step? Somebody should tell us the next step. Half mark again. The first 5 persons to tell us the next step, I'm going to give you half mark. Yeah. What is the next step? The next step. No. If you can see what I am saying, look at the board very well. Remove the bracket again. No. Yeah, this person said divide through by go on, Abdurrahman. I'm owing you divide. Yeah. I love that. Go on. Please remind me in class. Half mark. It's okay. Divide. Yeah. Go on. You get it. Yeah. Okay. Divide through by x plus 2y. I love that. So here the y all over the x, open bracket x plus 2y all over x plus 2y equals to minus 2 minus y all over x plus 2y. So this and this will cancel. We can now see that therefore the final answer will be now dy all over the x equals to minus 2x minus y all over x plus 2y. Can you see now? Look at the board. Please, I want you to like. Yeah. A18, we are active, sir. Colin, sir, you are welcome. C12, you are welcome. C9, you are welcome. A5, you are welcome. I can see you guys. I can see you guys. Thank you, Nasir Ahmed. God bless you too. C22, you are welcome. C1, you are welcome. Favor Moses. Okay, so let's look at another example. Please, I want you guys to like. And don't forget to share it. I'll be very grateful. It's okay. So let's consider more example. They said we'll look at 2 more examples, then we'll call it a day. Is that clear? They said find the slope of the tangent line at point. Okay. Those of us, or those of you that don't understand, when I come to class, I will explain it better. Then the video, you go back to the video to learn more so that you don't forget. Is that clear? It's okay. Another example says, find the slope of the tangent. Find the slope of the tangent. The tangent line at point at a point x naught, comma y naught, b square x square plus a square y square equals to a square b square. Look at the board, everyone, please. Everybody should look at the boards. This is another question. Musa Abubakar, I'm not saying sir. Sorry about that. Is yeah. God bless you too. Amin. God bless you too. God bless you too. Oh, your phone power is down. Moses, kinda. C29. My network, sorry about that, please. But I'm live here, it's clear. It's okay. So let's look at this problem. It's not difficult. you can now see that the line at point x naught, y naught is simple as ABC. So now what we need to do is the same approach. Don't get confused with the b square, a square. Please, what you after is the dependent variable and the independent variable, which you know that we have x and y. Is that clear? So any other thing should be taken as what? A constant. Is okay. So far so good. We write solution. Our b square x square plus a square y square equals to a square b square, right? So d all over dx, open bracket b square x square, then plus d all over dx, open bracket a square y square equals to d all over dx, open bracket a square b square. Let's do it together. So it means b square is a constant. Two of us. Remember this, please. Remember this. That is how it is. Don't get confused. Is that clear? So b square is a constant. So when you differentiate x squared, what are you supposed to have? You are supposed to have 2x. So easy to multiply b squared, you are going to have 2x b squared, then dx all over what? Dx. Because it differentiated for what? X. Then plus the same thing applicable here. When you differentiate y squared, what are you supposed to have? 2y a squared dy, true or false, all over dx equals to, who can tell us this? A square and b square, they are all constant, true or false. Why? Because we cannot find x or y. Supposing we have x here, we would have differentiated to give us a square, b square. But since y and x is not attached to this, it is automatically what? A constant. So here will be what? 0. Do you understand? Please take note. Do you understand? Okay, so let us proceed. Let's proceed further. Let us proceed further. Is okay. So if you can see what I am saying, this and this will go, two of us. So here we are going to have 2x b square plus 2y a square dy all over what? The x is equals to 0. Amen? So as you can see now, we are looking for dy all over the x. So we take this to the right hand side. We are going to have 2y a square dy all over the x is equals to minus 2x b squared. So what we do, we divide through by what? 2y a squared, two of us, in order to obtain dy all over the x, then divide through, amen, through by 2y a square. So it means if we do that, we are going to have our dy all over the x is equals to minus 2x b squared all over 2y a squared. Can you see now? So 2 will cancel. Then this is the same as minus x b squared all over y a squared. Then at the points, you know, in geometry, the coordinate system, here we have two coordinate systems, x and x, that is x naught, y naught. So it means x is equals to x naught, y is equals to y naught. So anywhere you see x, you write x naught. Anywhere you see y, you write what? Y naught. That is what it means at a point, that is tangent line at a point. X is x naught, y is y naught. So here, our final answer will now be our dy